They've all contributed greatly to the LangChain SQL efforts and have a lot of wisdom that I hope we can get out of them in this panel. And I wanted to thank everyone here for attending. With that being said, I'm also really excited that we're going to have a better moderator than me. So we've got Charles here from Full Stack Deep Learning, who's going to make this a professional event. And so with that being said, I'm going to hand it over to Charles.
Yeah, great. Thanks for the intro, Harrison. Yeah, so I'm here from Full Stack Deep Learning. We do education, online teaching for deep learning, and now for LLMs. And yeah, so I'm excited about this. Everything with LangChain in general. Every week I hack on a project, and then the next week LangChain incorporates the exact boilerplate tooling, prompt templates, etc. that I just wasted my time doing instead of making cool apps. And so I really appreciate the work. And now one of the latest additions is additional features for working with SQL databases. It's like a big capability unlock for language models to make sort of like accessing organization-specific data or project or problem-specific data easier and smoother. And so I'm really excited to hear from some of the people who built this integration about what they did, what it can do for you, and what the future of this integration between language models and relational and other databases is going to look like. So I'd love to hear just like a quick intro from the folks from Ankush, Francisco, and John, maybe in that order, and then we'll dive in, talk about the blog post, and talk about the integration. So Ankush.
Awesome. Thanks. I'm Ankush. I'm a co-founder of LangChain. Work very closely with Harrison. Before working on LangChain, I worked at a couple of other startups, including Robust Intelligence, which is where I met Harrison. And then before that, I worked at Facebook for 4.5 years. I was working on data and ML infrastructure. I'm super excited to be here and talk about SQL databases. And I'll hand it off to Francisco.
Thanks, Ankush. So my name is Francisco. I got into deep learning through FastAI a few years ago. And I worked a few years in a big tech company here in Latin America, which is mainly e-commerce and finance, fintech. And I recently left my job, and I've been diving into LangChain and hacking away with this tool because I'm really fascinated with it. And the main things I've been doing is related to SQL. So this is probably the area I'm most interested in. So with that, I hand over to John.
I'm John. My background is a little different. I'm a bioinformatics analyst at a research hospital. So I'm working with large genomics and healthcare data. And I got to the LLM game a bit late. We work with a lot of non-coders. So the idea was, how do we look at all this data without needing to code? And then LangChain was kind of a revelation with how easy it made working with these. So totally excited about that. I've been slowly contributing, and I'm excited to learn from all you guys today too.
John, you're not late to the LLM game. It's just getting started. It's still the first days.
I'm late to a new game.
Yeah. The vast majority of language model applications are still in the future, which is an exciting time to be alive. All right. So John, Francisco, I think you wanted to talk us through what you built using this blog post as our kind of like redneck slide deck. Maybe take it away from there.
Absolutely. Yeah, just a small mention that this is like a collaborative work. There are people that have contributed to it. So we are going to present here, but there's lots of people that have worked on this too. So basically, the objective here is to try to get LLMs to be able to query databases efficiently. And when we talk about doing this, effectively, there's probably two aspects of it. One is writing correct queries, and the other is getting the right information in the query, so that the query actually gets the data that we're looking for. So that's basically what we're trying to solve here. And many of the things that we will be talking about here are like they follow the philosophy of trying to tell LLMs or help LLMs do what we would be doing as data scientists when we are trying to query a database. Since LLMs are the interface with LLMs is language, we can just tell them and give them information that we would need if we would be querying these databases. So basically, we have in LangChain a few ways of using SQL LLMs to query SQL databases. One's mainly divided into chains and agents. We will not dive here into the differences, but can get more information in the documentation. And this is some kind of motivation here because, as we know, most companies have their data in SQL databases. And this means that if we make advancements in improving these solutions for this problem, we can help a lot of people in the business world to effectively get the data they are looking for and remove some of the barriers that are there today to actually access relevant data. So a few problems that we face when we want to make LLMs query SQL. One of them is hallucination, which if somebody doesn't know about hallucination, it means that the LLM invents basically the answer, and this is something we don't want. We actually want it to return an answer that is based on the data. And then also the context window length. If we just send a lot of information from the output of an SQL query to the LLM, it will max out the prompt, and this will basically break the LLM. So we need to get the results from the SQL database that are short enough so we can fit them into the prompt. And then what I was saying before, the LLM just sometimes it messes up and it might be incorrect. So we need to try to help it to be as correct as possible.
Just a quick question. So you mentioned that you want to use the SQL queries to find information to put in prompts. And I'm curious how you see this approach lining up with other approaches to getting more information into prompts, like using retrieval from vector databases.
So I think they are complementary. I think that they cover different use cases. So when I'm talking here of incorporating information into the prompt and trying that information not to be overwhelming for the LLM, the case I'm thinking of is when you send a query to the database that the LLM generated and you get an answer, that answer might be too big. And you still need to send some output from the database to the prompt to be able to answer the question. But you can't really vectorize it because you can, but I don't think it will work as effectively because you'll be sending a lot of rows, and you should have to find similarity with some of these rows, but these rows are actually the actual answer, so you wouldn't know what to look for with a similarity metric. So I think they cover different use cases, and here the main point is when you get the information back from the database, you should try to get that information as precise as possible. And maybe here there is a parallel line that you can draw between databases and this SQL querying, that you try to make the information you retrieve as high signal as possible. And in vector databases, you can do that by improving the embeddings or improving the similarity metric. Here, you can do that by prompting better, basically. I don't know if some of the guys here wants to chip in, but that's my view.
No, I think that was super clear. Thanks.
Okay, so yeah, so I go directly to each of the tricks that we incorporated into LangChain to make this querying better. And I will hand over here to John for him to explain how describing the database actually improves the LLM's performance when querying.
Yeah, so we went through a couple of iterations of this. The question is, how do you best represent a database structure to an LLM for it to most effectively query? And the previous iteration was simply saying, here's the table name, here's the columns it has, and the data types. And we linked to a paper, but following best practices from literature, we use the create statements, the table DDL. If you want to scroll down a bit. Yeah, and this is a good representation of what a table contains, the data types. It has the keys, foreign keys and references, which provides more information to the LLM. And then if you have comments in your create statements, that will also provide more context to the LLM. So this is an effective way of showing what a table can contain. But that's not always enough because it doesn't really show what the data looks like. And so one way to do this is we can include a few example rows from each table to the LLM so it knows, it can see what it's looking at and what it's working with. So we added a sample rows and table info parameter, the default being 3. And this is what it looks like in the prompt. It gives the create statement, and then from each table, example set of rows. And this does improve the performance of the LLM in generating correct queries. And then sometimes, there are cases where you might not want the full statements, or you want to adjust the example rows. By default, in the prompt, we include the first n rows from the table. Sometimes these rows might not be the most informative if there's not enough variety, whatever. So you can provide custom definition instead of automatically pulling through LangChain. So here's an example of the track table where I'm only giving it 3 columns to work with, and I'm changing the example. And you can also add, if you want to add more context, like describing what the table is, like you might say the track table contains tracks and their composers. You can also add that here. Yeah, so this is just a way to add some more context and customize the prompt a bit more.
And John, I think you bring up like an interesting point here about the sensitive data part. Would you mind explaining what that's about? Because I imagine we have a lot of people on the call that are in enterprises and constrained by some data constraints, which is very real. And so yeah, I think it would be interesting to talk about that.
Yeah, this came from my use case. I work in a hospital. Let me preface this by being absolutely clear. I'm not using LLM in any healthcare decisions. Just dodging that point. But yeah, if you have sensitive data, protected health information, you have names and things you don't want to send over the API, you can use this custom table feature to change things. Like you can make fake names, you can mask data. It's a way to de-identify whatever you send over the API. And I also want to make the point here that by default, the SQL database chain will query the result and then send it over the API to interpret it. If you want to avoid this, there is a return direct parameter that you should use, and that will just run the query and then stop there. It won't send the results back to the API. So yeah, it's important to keep this in mind if you're working with sensitive data.
And I think right now we let people pass in the full description. It could be a cool addition to automatically mask that data or something and use. That's probably more complex than I'm making it sound. I'm sure there's a lot of subtleties under the hood, but automatically generate kind of a fake data example based on real data before sending that to the LLM. Just another feature request that I'll open a GitHub issue for.
Yeah, that'd be cool.
Great.
I'll pass it back to Francisco here.
Thanks, Sean. I think there are 2 things that are really interesting about what you explained. One is that a source of inspiration for what we can do to improve LLM SQL interaction is basically telling the LLM what we would want to know if we would be querying this table. So for example, as John was saying here, this create table statement is nothing but a very complete description of what the table looks like, right? It has these columns, these are the types. So these are all pieces of information that are useful for anyone that needs to query that table, right? It's an understanding of what the table contains, and that helps anyone make an effective query. Same thing with selecting the rows. By seeing the rows, the LLM, as well as a data scientist, can understand what format the data has and can query it better. So I think that again, we see here that telling the LLM useful information is something that also, if we would be doing these queries, we would want to know. So it's a nice inspiration to think about other improvements. And another thing I think is relevant to say here is that all these improvements that John worked on are also in the literature. So that's another source of inspiration that it sometimes is even more complete, because it has all the suite of evaluation, and so it's really nice when things that you can see in the literature that work well, then you try them out, and they actually work well in practice and in experiments. So that's another source of inspiration that I think is great for new improvements.
Francisco, kind of provocative question. How often in your experience do the things reported in the literature in fact work when you try them?
So that's a great question. I think regarding LLM SQL interaction, this is the only paper I have read that actually puts out very concrete practices. And I don't usually, I try to find things that work for me, and I don't, I might see something and that may be an inspiration, but I don't go to the literature to look for them. I just think and I experiment, tinker. But actually, John brought this and this paper, and I think it makes a lot of sense. And I haven't tried it, I haven't done a very a litmus test. I don't know how you say it, to compare results that are really complete in a cohesive way, but it looks like it works better and it makes sense. So I don't have many papers that really give this level of concrete practices to actually use in practice for LLM SQL interaction. But I think if there are papers that find new things, I would be definitely glad to try them out, because I think there's a lot of space for improvement. Okay, so the other thing I mentioned also in the introduction is constraining the size of the output. So if we just send raw output from the SQL database, it might be too big and the prompt might be maxed out. So we try to, as best as possible, to send information that is highly relevant, and try to not send too much information to the LLM to actually answer the question. So two ways that can work for this are trying to constrain the number of columns and trying to constrain the number of rows in the result. Usually, the number of rows we need are just a few for most queries. So if we don't specify the LLM to use a limit clause, it might just return without a limit clause, and the number of rows would be unmanageable. So we added a top K parameter, which you can use. And this top K parameter basically includes a limit clause in the query, or a top clause, depending on the dialect. And that basically reduces the size of the output to something that won't afterwards break the LLM when it has to ingest that information. And finally, here we have another very interesting improvement. I don't know, Ankush, if you want to present this, or I should, because
actually, Francisco, there was a question relevant to what you were just saying about the top K parameter. So it should be popping up on your screen there, that sometimes they've noticed that the SQL statements can be wrong based on SQL engine. So you mentioned that there's like a difference between top and limit, right, depending on SQL dialect. So I'm curious how you've resolved this problem in the past, whether you've seen this problem as well. If you have any suggestions for Ahmet here.
That's a great question. I think John actually solved this problem, so I would defer to him to explain how.
Yeah, I can chime in a bit here. I think this is an ongoing prompt engineering issue. We do in the prompt say, generate syntactically correct X dialect like MS SQL or MySQL, and It's worked on my end. See, the tricky thing here is we can't. It's difficult to test across all the dialects, but I think if you're having issues, the way to go is yes to customize the prompts, or to experiment with different models as well. I was using Codex, and I don't think I ran into that issue when I was testing for MS SQL dialect. It was generating the top statement for me. But yeah, this is an ongoing thing that we're trying to work out in the prompt.
Yeah, and I would say if for someone this isn't working, please mention it in the SQL Discord channel or raise an issue so we can be aware of that.
And just to highlight what Francisco means by the SQL Discord channel, in the LangChain Discord server, there's a dedicated Discord channel for all kind of like SQL issues. We've seen this be a big community use case, and so yeah, just want to highlight it there. And I'll post the link to that channel in the chat in case people aren't already there.
Right. So, do you want to present this, Ankush, or should I?
Sure. Yeah, I can take a stab and walk them through this. Awesome. So yeah, checking the syntax is really important, especially when you come across an error. Originally, I included this as part of the SQL agent. So it's a tool that the SQL agent can use to recover from errors. And so what's happening under the hood here is we've given another tool to the agent that is an LLM chain under the hood. And the prompt in the LLM chain basically has like a number of common errors that you see when executing a SQL query. So the agent is able to grab the relevant tables with the tool. It's able to get like the relevant table metadata, as Francisco and John described earlier, and then it is then the agent like checks the SQL with the SQL checker tool, and a lot of the common issues it usually finds and like rewrites. It's not perfect, but it seems to work most of the time. And then another useful application of this specific tool is if the agent comes across an error, such as the one highlighted here, it actually uses the tool to make sure that there wasn't like an obvious like syntax error, and then tries to rewrite the query and executes it correctly. So yeah, this is something that we're still working on and like trying to tweak. So yeah, any suggestions are welcome there. But, yeah.
Thanks, Ankush. All right. So
I'm curious if you considered using like linters, like code quality analysis tools, sort of like software 1.0 tooling, as like a tool that the language model can use to check its SQL before running it, or as part of this process.
Yeah, that's it's definitely a good idea and something that I thought of. I didn't get the time to implement it. I thought that the LLM approach would be the most interesting. But yeah, that's like a software 1.0 approach could also be more efficient and potentially better. So just need to experiment a bit more.
Yeah. I mean, if we add software 1.0 and software 2.0, we get software 3.0, which is obviously better. So we got to.
Correct. Yes, that's a great point.
Awesome. So thank you, Ankush. I think here again, like the inspiration, at least for me, like when I went, the common factor I see is, okay, what would happen if I run a query and I get an error? What would I do? I just run it again. I just see the error, fix it, and run again. And why can't I send this to an LLM and the LLM corrects itself after a traceback? And that's actually what Ankush worked on. So I think like it's a very powerful inspiration just thinking about like, okay, the LLM is failing in this. How would I fix this? And how can I tell the LLM what I would actually do? So in the future work, we want to continue to improve this. I should say that these are a few things that we have thought of, but definitely not comprehensive, and we would love new ideas and new contributions from the community. So basically, few short examples. In the same paper that John was mentioning, they found that adding a few examples of questions and queries actually improve performance. So that's something that we could add. And then using subqueries, this is basically related to chain of thought. So if asking the LLM specifically to think in subqueries and add comments on what it's doing in each step, basically the think this problem step-by-step paradigm might help it improve the queries it makes. So this is something that we would like to try out as well. So, but I insist on the fact that these are just a few ideas, and this is a very fast-moving field. So if any of you knows any paper that is interesting for this topic, or have found that some practice is actually useful in your use case, please, as Harrison said there, the channel, you can write it there. We can discuss it.
For the subquery one as well, like I wonder if that's a pretty natural tie into the agent, because I think a lot of the agent prompts we have kind of break things down step by step and try to think about it in that capacity. So I think, yeah, I mean, it might also be good to touch on like evaluation while we're here. Like I think like there's so I think, yeah, like how actually, like before we get into like formal academic ways of evaluating this, just like how do you guys evaluate this when you're just like messing around with it on your own data or anything like that, or regardless of kind of like academic settings?
So in my case, I'm really not rigorous, but what I do is I run something. If I get an error, I try to fix that error. So it's really a greedy approach, very greedy, and definitely not reproducible. And but for practical, very specific use cases, I found it works well.
Do you have like a list of test cases that you like run over if you're making a change or something to like see if that error pops up, or is it just kind of like ad hoc as an error pops up in your like day to day that you kind of like look at it?
I don't actually, and I think that's a very important part, improvement opportunity, like having easily runnable code, but that can evaluate a specific prompt, for example. But at the same time, it's hard because like generic evaluation suites maybe are not specific to the different problems or questions you might get for a specific use case. So I think that it's definitely better than nothing, like having running a common benchmark, but probably the optimal way to do it is to build a few, as you were saying, like a few test cases applied to a use case that that they are usual, they happen a lot, and see that you're not making anything worse, at least.
Yeah, so my process has been, I have users trying the text to SQL, and if they run into errors, they fill out a form saying this is what I tried to do, this is where it broke, send it to me. And then I rely heavily on using few shot examples in my process. So generally, I found the best way to fix these is to provide more examples. And then I'll take whatever they tried and errored out on that prompt and run that. I do have an evaluation suite for problem things that we've run into, so I'll alter that a bit, and then test that each iteration I go.
And so, John, just double clicking on like the few shot examples part, do you just do you put them all on the prompt, or do you have some kind of like selection mechanism that chooses like the ones that are most relevant for like the incoming user query at runtime or something like
that? Heck no. Prompt is way too quick. The contact point, I mean. So I do I'm experimenting between just the similarity example selector and the max marginal. And I haven't formally evaluated them, but they both seem to work well. Actually, I can demonstrate something quick, covering both few shot and the subqueries.
Yeah.
I think actually, John, it's we wanted to switch over to audience Q&A. So there's a ton of questions coming in, and a lot of good ones coming in that Q&A area. Maybe we'll hold off on the demo. And
Sure.
yeah, I think there are a couple questions that came in. One, the highest upvoted one here, is asking, will there be a chat approach? And do you think that there's room for a more chat type interface to, as Marston puts it, talk with the database with natural language?
Yeah, I think this is especially relevant for the agent use case. If you're asking a high level generic question about your data that requires multiple steps that the agent needs to take, multiple queries, and then maybe do some transformations on the data before making more queries, or querying a different database, having some user input to validate the query or to validate the results would be awesome. So I think that's I think this fits in pretty nicely with the agent approach for querying SQL databases.
Yeah, even simply, so in my app, I'm using just the conversational React agent, and it's working well. It'll write you a query, you can give it feedback, it'll rewrite the query. It's pretty plug and play, actually. You don't need to change much for it to have a good baseline.
And so, John, when you're using the conversational React agent, what are the tools that you're hooking it up to? Is it the SQL toolkit in its entirety? Are you hooking it up to an individual SQL chain?
Yeah. So for my purposes, I made my own toolkit because of the limitations of the work environment. But I have a SQL generator chain that I'm asking to generate the code for me. So that's the tool I'm using. And then I have others for, vector, DBQA, and
Sense.
Okay. Yeah, so a couple questions that came in that were about alternative ways to get the data model into the prompt, because I think people were, talking about how it takes up a lot of space in the prompt, and you want to maybe limit which columns are visible, or limit which tables are visible. So yeah, I'm curious, have you looked into things that look more like soft prompting or fine tuning on specific LMs that become a specialized LM for use with these SQL chains for answering questions about your personal or your organization's data?
I'll take a stab at this too. So the simplest thing you can do to simply try to work with the context limit is you have a chain to select which tables to include in the prompt. So choosing only the tables that are needed to answer the specific question. And there's an example in the documentation of doing that with simply the table name and the column names. If you have a case like mine and many others where your table names or your column names are really esoteric or just a bunch of abbreviations or whatnot, you can have a prompt where you just describe your tables in a sentence or two, and that still saves on a lot of tokens over the full DDL. And then use that to select the tables, and then it will only include those table descriptions in the prompt. So that shortens it a lot. If there's this guy in the Discord that said he had 1,200 tables or something, there was something I started playing around with. If you have a data dictionary, you can embed the data dictionary and try to do some retrieval off of that for finding, what tables you need. There are a lot of options. It's pretty exciting.
Yeah, I think the agent right now has a few tools for interacting with SQL. So it one of the tools just lists the tables, and so the agent can choose which tables are relevant just based on the name. It's not perfect, but I think it works for for a lot of the use cases that I've tried. And that way you don't have to like stuff the information for every single table into the prompt. Like the agent is able to, you know, figure out like which tables are relevant to the query and then only get the information for those tables. And it's usually just like a few tables at a time. If you're making like a really, really involved query, then, you know, it's likely to break down there.
Another question that I think is probably on lots of people's minds. So, question from Nipun Jain. So earlier this week, OpenAI deprecated all of the Codex models, which technically were in beta. They are still available, but only for research purposes, so only through the research program. And this is a bummer because Code DaVinci 2 is possibly the most capable model available publicly anywhere, not just for code. And it's also what a lot like the text to SQL paper is on the Codex series. Lots of the results that people have been sharing have been on the Codex series. So what are the plans, like narrowly, like what do people think about like how to solve this problem short term? And then also sort of like long term in making sure that, you know, important open source tooling like LLM SQL combos is not like subject to the decisions of a single organization.
One first question that I have for Francisco and John: are you guys using Codex in your kind of like day to day, or have you migrated onto like GPT-3 Turbo or something like that?
I am using Codex. It was free. You know, they didn't give us much heads up for when it would be shutting down. So I'm currently trying to migrate.
Onto what?
Have you?
So just the chat model. There's some weird formatting issues that I'm working through, but I think it's a good default in terms of, you know, its ability to generate SQL.
Yeah, I'd actually be really curious to hear what are those weird formatting issues.
It likes to talk, man. I don't know. So again, that's just another prompt engineering issue, and yeah.
Yeah. So I have two like more comments than anything really insightful there, but like one of the things that we've been adding partially in response to this these chat models, which like to be very verbose, is the idea of like output parsers, which help kind of like structure information. It's mostly used kind of like when you have like multiple fields that you want to return, and you can structure it as like JSON or something. But I wonder, but it's really good at it, or it's pretty good at basically like I think Jeremy who wrote the parser like made it ignore a lot of the chat stuff on the side as long as it sees some valid JSON. So you could just ask it to return a SQL statement as valid JSON or something like that. I would give that a look. And then I think the other thing, and there was a great question about this in the chat around like, and it ties into this, is around like evaluation and having these data sets to run on. And there was a question about like the OpenAI has like their evals thing. And so I have like two comments here. One, like we are trying to do this for end-to-end chains within LangChain. So I'll send a link in the chat shortly. But there's we're putting it on Hugging Face because yay open source. But yeah, we have like it's really simple. It's just like 10 examples of running with on the Chinook database that's in the all the default LangChain stuff. So for like testing out stuff like this, and I like what Francisco said about like, you know, just making sure it doesn't break. Like that's kind of like the main thing. And so even if there's not like amazing like end-to-end evaluation things, having just examples to run on and make sure it doesn't break absolutely is a focus.
I think
instead of sending the link, I muted myself. So need to work on that. But I'll send a link around that. And then there's also like more. There's like a spider data set as well. That's kind of like a more academic data set that I think we should look at and have an example of hooking that up as well. Because I think, yeah, you know, all these models require different prompting strategies. So just having a really easy way to run and evaluate, and even if evaluate means don't break, that I think that's a very legitimate way to evaluate things.
Yeah.
I think there was a question about software 1.0 approaches earlier. I think actually output parsing kind of ties into this. So like the ability to try to parse an LLM output into SQL, and if it fails, like having just like a detailed error message that an LLM can interpret and try to fix and try again until like the parsing succeeds. And we can do that before, and this can potentially like take the role of like the SQL checker tool that we have, which uses an LLM right now. It's way cheaper and faster. So, yeah. And another question, like, has anyone tried doing like working with SQL queries with GPT-4? Like, any thoughts or early results there?
Not yet, but if you look at Eric Drew, I think on doing a lot of cool stuff on Llama Index, he did some evaluations on the different models, and I mean, it is performing the best. It's slightly outperforming the Chat 3.5 model on the portion of the Spider benchmark that he was running.
Yeah.
I also said that GPT-4 is performing better, so not terribly surprising.
I saw the same benchmark there, John, and something that is also relevant regarding the question before is that in that same benchmark, the Code DaVinci model, so basically Codex, performed much worse than DaVinci 3, and GPT-4 and GPT-2. So they all perform close with each other, but the one that really was different was the Codex that was quite worse. So I haven't tried it myself. I've been always using DaVinci 3, and I have had great results. But I think it's the fact that Codex is deprecated now doesn't mean that we will get worse performance. It means, as John said, that we don't get a free model.
Got it. So I think evaluation in terms of the like correctness of the model, tough problem. Academic benchmarks, not great. Maybe bringing some unit testing, regression testing ideas from software is helpful, as has been discussed. There's another objective of evaluation, which is like, how quickly does this run? You know, how well does it scale? Are we writing like SQL queries that can handle thousands of tables or tables of thousands of columns or high cardinality columns or whatever? So I'm curious, to what extent has this even sort of like come up as like a potential objective? Have you started to hit limits of like these SQL queries are just like not well written, so then they don't run well? Like, to what extent has this come up at this stage of working with LLMs and SQL?
I think, yeah, this ties pretty nicely into data warehouses, which I meant to bring up earlier, but didn't get a chance to. So a lot of our work has been like very relational database centric, and we haven't spent a ton of time addressing like the data warehouse use case where this like optimization problem is like most relevant. So like data warehouse, when you're creating your data warehouse, like you're querying like a ton of data, and you want to make sure that the SQL that you're executing against the data warehouse doesn't cost you more than it should. You know, at my time, like working in data infrastructure, I've seen like queries that cost like thousands of dollars, right? And so if you can reduce that, you know, cost per query or make it more efficient, that's like really important, especially for the data warehouse use case. And there are a couple of tricks that you can do. Like multi-statement queries is like one thing. So instead of like querying the data warehouse like sequentially, you condense like all your queries into a multi-statement query, and usually like the data warehouse has some tricks that it can do to optimize the query plan. Another thing that's like you know, that could potentially save compute here is ordering joins by table size. So it used to be the case that you shouldn't do joins and data warehouse queries at all. That's like not that's not as much the case anymore. A lot of them and a lot of the data warehouses like BigQuery have been working heavily on you know, allowing for like efficient joins, but there's still some tricks you can do to make those work better. But yeah, I think the gist of it is like, yeah, warehouse queries tend to process much more data for like analytics use cases, and making an LLM understand what what tricks to employ to make the query more cost effective is super important. So that's something that we should definitely explore in the future.
Yeah, I wanted to also double click a little bit on the sort of like data warehouse and BI sort of side of things. It seems to me like sort of a lot of the SQL that people write is fairly simple, and Ingo in the chat said like generating SQL is one thing, but SQL is so simple. Not everybody thinks SQL is simple though. A lot of people need information from databases that is locked behind SQL and they don't have SQL knowledge, and a natural language interface like a language model maybe opens that up to them. But then there's also folks like Nipun who have been asking questions about like highly optimized queries and like really complex tables. So I'm curious, how do you see the divide between like providing features for LLMs to like open SQL for everybody, from NoSQL to YOLO SQL, versus like making SQL like a more powerful tool for people who are already power users? Like, which do you think is more exciting? How does that tie into your vision of like the future features for this tool?
I think ideally both. I think if LLM-based tools get good enough, they can be great assistants for even experienced analysts or engineers who are like using SQL in their day-to-day and have a lot of knowledge. I think, especially like for the data warehouse use case, like if an LLM can flag something like a query is being inefficient even before you run it, like that's potentially like really interesting. But yeah, I think it definitely also opens up the door to new users who are trying to make sense of their data, who don't have a ton of SQL knowledge.
My gut kind of tells me, like in my experience with language models, that the less common something is on the internet, the more complex it is, the like more likely they are to get it wrong, and then there's always the problem of like hallucination of, in this case, like the perfect column, that if that column existed, your query would be easy. Language models would love to hallucinate that column and then include it in the query. So like my gut is telling me that the thing that's going to be easiest is like unlocking SQL for BI people who are more comfortable in like a spreadsheet program, or people like me. I'm not really a SQL expert. I'm like an ML person. I love math and fear databases. And so like it feels that feels like a really big addressable sort of like user base, but and also like easier to do with LMs than like nailing like really complex queries or nailing query optimization or what have you.
I think also like what I'm guessing that we'll see is that for those more complex use cases, the solutions are actually pretty specialized. Like John's already saying that he's kind of like building out kind of like a specific solution for his company. And I think that's absolutely the right place. So if I had to guess, like LangChain will provide like a starting point, and will provide some of these primitives around example selectors that maybe people can use downstream. But I think like the really complex stuff, I would imagine people, other engineers building that out and making it more specialized. I just, maybe we'll get to a point where AGI is so good that that's not needed. But I think like right now, like I think, as you said, like yeah, the common stuff, great at that. I think we'll make sure that the LangChain stuff are awesome at that out of the box. But for the more complex use cases, I don't think it's at all like bad. I don't think it's bad at all that people have to specialize. I think it's good. Like I think it's a really hard problem, and it's expected.
Great. I think there was some interest in some of the data warehouse stuff, and I know that Ankush wanted to talk a little bit more about where y'all see the sort of like specific applications for LLMs and SQL in data warehouses. Was there more than just what we talked about in terms of query optimization, or was that the primary thing you wanted to talk about, Ankush?
I think, yeah, so query optimization is one thing. Obviously, we need to build integrations with different data warehouses in LangChain. So right now we use like SQL Alchemy under the hood, which allows us to connect to a number of relational database management systems like MySQL, Postgres, SQLite. But yeah, we need to build some integrations with the common data warehouses like BigQuery, Snowflake, etc. So that's another thing that we need to do. Yeah, and then like the SQL dialect tends to be like a little bit different. So getting that to work well and allowing the LLM to generate the right dialect is also important. And then yeah, just making sure the LLM isn't writing like a super inefficient query that's going to cost you a lot of money or more money than it should is important. So there's the main points I had about data warehouses.
Got it. Yeah, on that topic of sort of like creating specialized connectors, like the first problem that I ran into is when I wanted to use like a Postgres extension, it was difficult to use like I couldn't get normal SQL Alchemy to work, and so then I couldn't get the like LangChain thing on top of that to work because there's this like the vector type is not parsable into the DDL, so it feels like there's like the SQL world is like huge, right? There's so many extensions, there's so many dialects, there's so many like engines, and like query optimization is going to be like dialect and engine dependent and like data model dependent. So like it feels like there's a lot of really hard last mile problems. Is that something you see being solved, as Harrison like was suggesting, like with sort of like customization, maybe prompt engineering and like a little coding, like with something like LangChain to solve those problems? Is that something you think we can just get LMs to be smart enough that eventually they solve all those problems for us? What do you think?
I think potentially. I think there's always going to be a long tail that will be very tricky to solve. It'll be tricky to solve like all the edge cases for all dialects, for all engines. I think it would be great to get majority of the use cases working well out of the box, like maybe for like the top 3 or 4 like relational database management systems, or maybe like the top 3 data warehouses. And I think that should take us a long way. But yeah, we should always build things in a way that they're so that they're modular and customizable, and allow people to experiment. So yeah, that's sort of my almost like cop-out answer there.
I'll take it.
One thing I might add there, I don't know, please Harrison or Ankush, let me know if something is not right here, but what something I think might be interesting is like having some sort of primitive for something like the self-critique chain, which is kind of what the agent is doing when it's checking syntax aspects, but for optimization. And that might have like a predefined template, but people might be able to edit it with engine-specific aspects. So like probably there's an 80-20 here, where 80% most use cases there's a big long tail, and for the long tail you can always like open up some of the primitives for people to be able to customize them to their own use cases.
I think that's I think that's really interesting. I think that also ties into like the constitutional AI chain, which a great addition for people that don't know. It's based on like an Anthropic paper where they mostly use it to like align kind of like language models with humans. So the constitutions are like, don't be racist, don't say bad things, stuff like that. But you could absolutely write a constitution that's like, hey, this response needs to be like valid, like MS SQL or something like that. And then it will take in a query, it will critique it to see if there's any part of it that's not MS SQL, and it will rewrite it. And it will be like a little bit more expensive maybe, but if the costs of language models keep on going down, and if you really care about the last, like if you care about getting like to that high accuracy threshold, something like that could be interesting. I think we should, this is more a note to self than anything else, but we should make it kind of like possible to plug in these like constitutional critique chains instead of LLM chains wherever in the stack, because I think like they do really help for kind of like adding these guardrails and safeguards in.
Yeah, and if someone wants to add any like specific optimizations, like please try to do as least or as most subqueries as possible or something like that. That might even like save costs on one side, so it might balance out as well, or even be a positive net positive.
100%, yeah, and I mean like adding in another thing, because Nipun's having a lot of great comments in the chat around like giving an estimate of the cost query, like this is one thing that we need to figure out is where exactly like validation goes, but right now we have the concept of like an output parser and stuff like that, and so you could And so there's actually some validation logic in there already that the schema is in the right format and stuff like that. And so we need to figure out exactly where like this validation should go, but making it easy for people to plug in like, hey, this query should cost below like 1 cent or something like that. And then kind of like reject or retry. I think that's I think we maybe need to change the name output parser to make it clear that you can do things besides parsing. But I think like stuff like that, not only asking language models to critique, but using, again, software 1.0 things like cost estimates as this like trigger for retrying. Very interesting ideas.
Yeah.
There's a kind of repeated theme that's been coming up in the questions that I wanted to touch on, which is like, I think a lot of the work so far has been getting LLMs to work with RDBMS, right? It's like RDBMSs have been around for like 40 years. There's, so there's like a ton of tooling on them, and it's like, oh, let's interface with that. But and like people are bringing their ideas of like, I have this table, like how do I get an LLM to work with it? But there's another perspective, which is like, how do I change my data workflows now that there are LLMs? So an example question coming from Tofi here, how can I add extra context to each DB table to make sure the LLM has the information needed to create a query? There's another question about like, how might we, like, should we be changing our data models so they're more understandable to LLMs? I'm curious if anybody's thought about this. Is it like, oh wait, all of a sudden now like MongoDB is like suddenly way more compelling because like something about the document model is better for LLMs than like the like sort of schema centric data model, or like graph databases are the move because like knowledge triplets. There's a ton of work on knowledge triplets and language models. So just sort of like wanted to open up like a broader question about how might LMs kind of change the way that we store, query, and interface with data like all the way across the stack.
Yeah, I think the easiest thing that comes to mind is just having sensible names for your tables and columns. So that like, the LLM can interpret them better. Not too sure about changing your data model or changing the type of database that you're using, like a NoSQL or a graph database, because like for the LLM use case, I mean, I still think that you should use the best system for your application. If you need like a transactional database, you should use a transactional database. If Mongo makes sense, use Mongo. I'm curious to hear other thoughts too.
Yeah, I mean, I think the biggest thing is probably, making sure that the language model has the right information that it needs, right? And so if column foo is really the name of a person, you got to let it know that it's the name of the person. And so you can do that with better names. I mean, I wonder if there's a way to, maybe we should expose arguments for letting people kind of specify like descriptions of columns or descriptions of tables and inject those as well. I don't know if any like providers support stuff like that out of the box, but like if they, this is probably an open question for people that know a lot more about data warehouses and SQL stuff like me. Like, can you attach like a description of a column or of a table into it, like natively into the thing? If so, that would be awesome to do. It's basically getting the language model that information. And seeing some comments in the chat, so people probably know this better than me, but that would be, it really comes down to just tell the language model the information it needs to know in some manner. And so, depending on the warehouse you're using, probably different ways for doing that.
Awesome. Great. I think we're running close to the end of time here. So I just wanted to maybe open up for maybe like just with our one last minute, Francisco or John, if you want to like give some like high level statement visions of the future, or what you think is the most exciting thing that you can go and hack on right now that's been opened up by the like LLM SQL combo. Yeah.
Myself, I'm really excited about getting non-technical people to be able to interface with data directly. I think that's like something that was not possible a few months ago, and now like it's getting concrete and real. And I would encourage anyone that if anyone of you is interested in this topic, please come into the forums and just discussing on these topics and bringing new ideas into the table. I think is really very, very productive for for the improvements that are happening in the library.
Yeah, I'm extremely excited about the use of LLMs here for my field to browse these complicated genomic data and whatever you need, coding knowledge, you need knowledge of really specific bioinformatics software and tools. And SQL is a nice abstraction for that for us, where you only need to learn SQL, which is simpler, but even that, it's a barrier for a lot of people. And there's no more intuitive way to interact with data than to just simply ask a question, right? That's how you think. So this has been very exciting, and I'm having a great time playing with all this. Yeah, join us on the SQL Discord, or the SQL channel on the Discord, and yeah.
Cool. Yeah,
Charles, and if people want to learn more about LLMs in general, like, do you have any good resources for them?
Way to tee it up, Harrison. Yeah, so I am teaching a boot camp on LLMs. It's going to be live in San Francisco in late April. There's a link in the chat. Harrison will be coming and talking. We'll be talking about using LangChain. We'll be talking about everything from what the hell is a transformer to how do I build a defensible business in the current language modeling and artificial intelligence environment. If you can't make it to San Francisco in late April because you're in one of the other billion places on Earth, we will put video recordings of some of the lectures online and continue to teach the bootcamp in the future. So sign up for our mailing list, the Full Stack Deep Learning mailing list, also available at that same link. Yeah, so thanks for teeing that one up for me, Harrison. I would also like to say, just John, you mentioned how much fun you're having doing this. I just also wanted to say that the community is incredibly grateful. Both the LangChain community narrowly grateful for the work that you and Francisco and others on this project have been doing to make it easier, less painful, more delightful, and faster to work with SQL databases and language models. And then also just zooming out beyond the LangChain community, the incredible work that the whole LangChain community is doing to contribute to the broader world of people who are unlocking this world of new artificial intelligence. It's accelerated a ton of work that I've done. Everybody I've talked to has talked about how much they love the things that they get for free from LangChain. So tons of gratitude to everybody else on the call here for building some really, really awesome stuff.
And before we sign off, just final big thanks to Charles as well, for being an awesome moderator, awesome host. Yeah, it's been a really fun discussion. Thank you for all the great questions in the chat as well, and suggestions for filling in some of my lack of knowledge in areas. So yeah, I think we'll end it here, but big thanks to John, Francisco, Ankush, Charles, and everyone for joining. And we're going to be doing a lot more of these. I can't promise they'll be as exciting as this one, but we'll strive to make them so. All right.
Cool. Thanks a lot, Harrison.
Bye-bye.
Take care, everyone. Bye.
Take care. Bye.